Now, let's talk about the next great forces which rule the universe. We talked about gravity, which allows us to calculate the motion of the planets. The mechanics created by Newton helped to unleash the Industrial Revolution. Michael Faraday worked out the electromagnetic force, which gave us the wonders of the electric age. And now let's talk about the nuclear age, the stars and the sun. So what could possibly last for billions of years? There must be a new force, a nuclear force. Einstein and others helped to unravel the secret of the stars. The nuclear force comes in two types, weak and strong. The weak nuclear force governs radioactive decay. The strong nuclear force is one of the strongest forces in the entire universe. It's so strong, it holds our protons together ever since Genesis, the beginning of time. The equation which allows for the liberation of energy is Einstein's famous equation, E equals mc squared. What Einstein showed was that the faster you move, the heavier you get. So your weight is not a constant. When you move very rapidly, you get heavier, something which we measure every day in the laboratory. Now this means that the energy of motion transformed into mass, because you get heavier. Now listen carefully. The faster you move, the heavier you get, which means the energy of motion, E, turns into m, your mass. And the relationship between E and m is very simple. It takes 1 second to write it down on a sheet of paper. It is exactly E equals mc squared. So the nuclear force helped to explain the secret of the sun. But it also created a Pandora's box, because inside the nucleus of the atom are particles. And when you smash these particles, what do you get? More particles. And when you smash them, what do you get? More particles. In fact, we are drowning in subatomic particles. Now, we smash atoms using something called atom smashers or particle accelerators. I built my own particle accelerator when I was in high school. When I was in high school, I went to my mom one day, and I said, Mom, can I have permission to build a 2.3 million electron volt betatron particle accelerator in the garage? And my mom said, sure, why not? And don't forget to take out the garbage. And we wound 22 miles of copper wire on the high school football field. Well, finally, my atom smasher was ready. It consumed 6 kilowatts of power. That's every single ounce of power that my house could deliver. I plugged my ears, I closed my eyes, I turned on the power, and I heard this huge crackling sound as 6 kilowatts of power surged through my capacitor bank. And then I heard a pop, pop, pop sound as I blew out every single circuit breaker in the house. Well, these machines that I built in my garage earned the attention of a physicist, Edward Teller, father of the hydrogen bomb. And he arranged for me to get a scholarship to Harvard. And my career got a head start. He knew exactly what I was doing. I didn't have to explain to him that I was experimenting with antimatter. I was creating anti-electrons in my mom's garage and using atom smashers to eventually create beams of antimatter. Antimatter is the opposite of matter. It has the opposite charge. So an electron has negative charge. The positron or anti-electron has positive charge. This means that you can now create anti-molecules and anti-atoms. Anti-hydrogen was made at CERN outside Geneva, Switzerland, and also at Fermilab outside Chicago, where I have anti-electrons circulating around anti-protons. And in Brookhaven National Laboratory in Long Island, just recently, they detected anti-helium. We have 2 anti-protons with 2 anti-neutrons to create anti-helium. For every piece of matter, there's a counterpart which is made out of antimatter. And when the two collide, by the way, it releases the greatest energy source in the universe. It is 100% conversion of matter to energy by Einstein's equations, E equals mc squared. So let's talk about the particle zoo. Right now, we physicists have unlocked hundreds, thousands of subatomic particles. And we've been able to piece them together into a jigsaw puzzle. It's called the Standard Model. It has 36 quarks. It's called the Standard Model. It has 36 quarks, 19 free parameters, 3 generations of quarks, no rhyme, no reason, but this is the most fundamental basis of reality that we physicists have been able to construct. Billions of dollars, 20 Nobel Prizes have gone into the creation of the Standard Model, and it is the ugliest theory known to science, but it works. There's one piece missing, and that one piece that's missing is called the Higgs boson. We expect to find it. We want to create a higher version of this theory, and that theory, we think, is string theory. String theory is based on the simple idea that all the 4 forces of the universe, gravity, the electromagnetic force, and the 2 nuclear forces, can be viewed as music. Music of tiny little rubber bands. So if I had a super microscope and I could look right into the heart of an electron, what would I see? I would see a vibrating rubber band. And if I twang it, it turns into a neutrino. I twang it again, it turns into a quark. I twang it again, it turns into a Yang-Mills particle. In fact, if I twang it enough times, I get thousands of subatomic particles that have been cataloged patiently by physicists. String theory, we think, is a theory of everything. Now, string theory, in turn, can be summarized in an equation about an inch long. That's my equation. This is called string field theory. And how will we test it? We are building a machine, the biggest machine of science ever built in the history of the human race, outside Geneva, Switzerland. It is the Large Hadron Collider. So the Higgs boson, we think, will be created by the Large Hadron Collider, a tube 17 miles in circumference with 2 beams of protons circulating in opposite directions, then slamming together, creating a shower of particles. And among these particles, we hope to find the Higgs boson. But not only that, we hope to find particles even beyond the Higgs boson. The next set of particles beyond the Higgs boson are sparticles. The next layer of the jigsaw puzzle are called sparticles, superparticles, nothing but higher vibrations, higher musical notes of a vibrating string. And what else could we do? We can also unlock the secrets of the Big Bang. You see, Einstein's equations break down at the instant of the Big Bang and the center of a black hole. The 2 most interesting places in the universe are beyond our reach using Einstein's equations. We need a higher theory, and that's where string theory comes in. String theory takes you before the Big Bang, before Genesis itself. And what does string theory say? It says that there is a multiverse of universes. Where did the Big Bang come from? Well, Einstein's equations give us this compelling picture that we are like insects on a soap bubble, a gigantic soap bubble which is expanding, and we are trapped like flies on flypaper. We can't escape the soap bubble, and that's called the Big Bang theory. String theory says there should be other bubbles out there in a multiverse of bubbles. When 2 universes collide, it can form another universe. When a universe splits in half, it can create 2 universes, and that, we think, is the Big Bang. The Big Bang is caused either by the collision of universes or by the fissioning of universes. If there are other dimensions, if there are other universes, can we go between universes? Well, that, of course, is very hard. However, Alice in Wonderland gives us a possibility that maybe one day we might create a wormhole between universes. This is a wormhole. Think of taking a sheet of paper and putting 2 dots on it. The shortest distance between 2 points is a straight line. But if I can fold that sheet of paper, then perhaps I can create a shortcut. a shortcut through space and time, called a wormhole. This is a genuine solution of Einstein's equations. We can actually see this in string theory. The question is, how practical is it to go through one of these things? We don't know. In fact, there's a debate among physicists today. Stephen Hawking, many physicists are jumping into the game of trying to figure out whether it's physically possible to go all the way through a wormhole. Because if you could, then you might be able to use this as a time machine. Since string theory is a theory of everything, it's also a theory of time. And time machines are allowed in Einstein's equations, but to build one is extremely difficult. Far more energy is required than a simple DeLorean with plutonium. You know, trillions of years from now, the universe is going to get awfully cold. We think the universe is headed for a big freeze. All the stars will blink out. Stars will cease to twinkle. The universe will be so big, it'll be very cold. At that point, all intelligent life in the universe must die. The laws of physics are a death warrant to all intelligent life. There's only one way to escape the death of the universe, and that is leave the universe. We are now, of course, entering the realm of science fiction, but at least we now have equations, the equations of string theory, which will allow us to calculate if it is possible to go through a wormhole, to go to another universe where it's warmer, and perhaps we can start all over again. If you were to summarize the march of physics over the last 10,000 years, it would be the distillation of the laws of nature into four fundamental forces: gravity, electricity, and magnetism, and the two nuclear forces. But then the question is there a fifth force? A force beyond the forces that we can measure in the laboratory? And believe it or not, there are physicists who've actually looked very carefully for a fifth force. Some people think maybe it's psychic phenomena, maybe it's telepathy, maybe it's something called psi power, maybe it's the power of the mind, maybe consciousness. Well, I'm a physicist. We believe in testing theories to make sure that they are falsifiable and reproducible. We want to make sure that on demand, your theory works every single time without exception. And if your theory fails one time, it's wrong. In other words, Einstein's theory has to work every single time without exception. One time, Einstein's theory is proven to be wrong, the whole theory is wrong. Well, so far we can reproduce these four physical theories, but a fifth theory cannot be reproduced. We've looked for it. Some people think that maybe a fifth force may be short range, like not over the nucleus of the atom, but ranging over several feet. And we can't find any. We physicists in the last 10 years have discovered a new energy source larger than the galaxy itself. Dark energy. Realize that in our universe today, 73% of our universe, the matter and energy, 73% is in the form of dark energy, the energy of nothing. That's what's blowing the galaxies farther and farther apart. That's the energy of the Big Bang itself. Kids ask the question, if the universe banged, then what made it bang? And the answer is dark energy. 73% of the universe's energy is dark energy. 23% is dark matter. Dark matter is invisible matter. If I held it in my hand, it would go right through my hand. It holds a galaxy together. 23% of the universe is dark matter. Stars, made out of hydrogen and helium, make up 4% of the universe. And then what about us? We, the higher elements, we made out of oxygen, carbon, nitrogen, tungsten, iron, we make up 0.03% of the universe. In other words, we are the exception. The universe is mainly made out of dark energy. The universe is mainly made out of dark matter, overwhelming the stars, overwhelming the galaxies, in fact. Now, what is dark matter, which makes up 23% of the universe? No one knows. String theory gives us a clue, but there's no definitive answer. So in other words, for you young aspiring physicists out there in the audience, you may be saying to yourself right now, why should I go into physics? Because you guys already have a candidate for the unified field theory, right? Just realize that every single physics textbook is wrong. Every single physics textbook on the earth says that the universe is mainly made out of atoms, right? There it is. The universe is mainly made out of atoms. Wrong. In the last 10 years, we have come to the realization that most of the universe is dark. And there's a whole shelf full of Nobel Prizes for the young people who can figure out the secret of dark matter and dark energy. The thing about physics, or even science, that really intrigues me the most is to find the most fundamental basis for everything. Rather than trying to massage a theory or make a theory prettier, why not find out why it works? What makes it tick? And that's what I do for a living. I'm a theoretical physicist. Thank you very much.